Now we will see LED control with PWM. So have you noticed if you switch on the bulb, will it glow 100% or it happens like first it will glow like 10%, 20%, and its brightness increases rapidly for like 1 2 seconds, and after
Yes,
that
yes,
it attains its full brightness, or
yes.
when we press our switch, from beginning only it attains 100% brightness. Which case is right?
Could you repeat the question, sir?
If when you turn your lights on, so what happens? Case 1, it first glows 10%, 20%, 30%, and rapidly increases for like 1 second and then attains its maximum brightness. Or case 2, just pressing the switch, it attains 100% of its brightness. Which case is true?
'Will get
100%.
100% brightness.
No. Uh, it's an experiment you must do to check. When you will press your switch, or if when we you will turn your LEDs on or any light, so for a fraction of second it will start getting its brightness. So at that time it will glow like, if it have 100% brightness, so for that fraction of second, initial fraction of second, it will glow 10%, then its brightness will increase for 20%, 30%, and after that time it will attain its full brightness. These
So
things
initially
happen
it
in
will be
fraction of
zero
second. Yeah,
and it
zero.
gradually increases.
Yeah, when it's in off condition, it's zero. When you will turn it off for microsecond, its duty cycle will increase and its brightness will increase. So the bulbs glow initially, or you can check it
But in
yeah.
our real time condition, we can't see our naked that scenario, right?
You can see it with naked
So
eye scenario, and for that purpose, you will have to take
person confusing.
torch lights, small torch lights, or the old bulbs which we used earlier.
Yes, yes.
Or the third case is when supply voltage is less, sometimes due to transformer issue or load voltage issue.
First,
When
what
supply
is
voltage is
process?
low, you
What
can
is
see
multiprocessing?
the bulbs
In
glow
that,
very
how many
dimly.
types are there? In that,
Yes, yes. In that
like
condition, if the voltage is low,
more
automatically it would be like dim
for
Yeah,
only.
multi
yeah. So
device. Like yes, is
that's what happens at that time. The brightness
thank you.
attains just 30 to 50% of its maximum brightness,
Wait,
and
I
that's why
will
you are
terminate
able to
here
see
one more
only
time and
dim
I will
lights.
hang.
So dim
The
lights
same
mean
is coming.
it have low duty cycle, right?
Um, duty cycle is not something
Okay,
that we can correlate directly with the dim lights.
okay, okay,
PWM is your term. PWM that consists of duty cycle and frequency.
okay, okay.
You cannot only blame or give credit to a duty cycle only. You will have to give credit to PWM.
Okay.
Okay. So uh, one more thing. You have seen any motor working.
Yes.
So how does a motor start? I'm not asking about the scientific fundamental
I
that
start with
it,
slow speed and then
yeah, yeah.
gradually it's uh,
So what happens
And
there?
maintain
Yeah,
constant speed at
yeah.
high
So
end.
what happens there? For example, if motor have 100% speed, for example,
It runs smoothly.
yeah. So what happens when you turn it on? For a fraction of second, its speed will be slow. Then it will gradually, rapidly increase its speed, and after 1 to 3 seconds, it will attain its maximum speed and then maintain its maximum speed.
Yes.
So that's also happens due to PWM.
So the same scenario is going to be work out in the PWM, right?
Yes. I was giving you example of LED bulbs, but same scenario happens at many other places, like in servo motor controls that's used in robotics, uh, motor speed controls that you can see anywhere in your water pump or any toy which uses motor for speed control. So, at last, I would like to conclude by saying that PWM is a digital method by which we can simulate analog output by varying its on and off time. Using this, we can vary its time, like it will be on for that period of time, off for that period of time, and we can adjust its blinking and brightness. So, anyone have any doubt regarding the theory of PWM till now? Please speak.
Can
Because
we control
after,
the brightness by using a duty cycle?
yes, I will show you right now in this
Okay.
workshop.
So till now, the program we have wrote for LED,
Yes.
does it include the concept of PWM
No.
or
Have we ever used timer, PWM, or anything related to it?
no?
No. So till now we have not used PWM, and you
Okay.
can see if you turn your LED on, it gets its maximum brightness in one go only.
Okay.
Okay. Now there are two methods for a hands-on workshop. First, you will have to configure PWM timer that and clocks that will be auto generated by your controller and IDE. What you have to do, just at that particular pin you will have to connect your LED bulbs, and PWM will work. Okay.
What timer and
Okay, sir.
Timer, frequency, prescaler,
okay,
and PWM.
okay,
So these all things will be generated by STM32 and its IDE.
okay.
Okay, but here we will not be able to understand its core concept.
Got it.
So what I am going to do now, I will not use PWM and duty cycle generated by STM32 IDE and its controller. That we will also do, but first I will use some loop and software, hardware generated and software generated manually PWM type code. So we can call it fake PWM because we are manually generating it. Fine.
Okay.
So in this tutorial, we will write the code and see how using this PWM we can control the brightness of LED and its blinking time. Now I will share my screen and I will like uh, that all of you will open your STM32 QID. Everyone open your eye.
Yes, sir.
My screen is visible.
Yes.
Okay, fine. This is STM32 QID. I will just go to new and create new STM32 project. Here we will select our controller STM32 WB55RG. We will give this name like PWM1. Why we are giving it name like PWM1? Because here we are not using software generated PWM and duty cycles. Okay. Now we already know the pins of our LEDs. There are three LEDs on this board, and we know on what pin these LEDs are situated. Correct?
Yes.
Okay, so I will take any one, like for example
PB5.
PB5, PB6. So I will take PB5. PB5, make it GPIO output because LED pins are in output mode. And we have to only do this. Then just go one more thing I will like to show. Here, if you want to generate this with actual PWM, you can select any timer that I will teach you in next uh, hands-on workshop. It's simple one, and right now what we are going to do, we will generate all these PWM and all with our own code only. So we are not dependent on any IDE or STM32 controller PWM right now. So just on device control code, this will generate our main.c. Now, I have told all of you there are sections where we should write our code, correct?
Yes.
So we will go to our main code, int main inside this. After everything is in init mode. So GPIO is init mode. We have user code begin too. So here I will take two variables like uint 16t, and I will take first duty cycle. So just duty and initialize it with 0. Fine.
Yes.
Again, I will take one flag. Flag will be of 8 uint 80, and I will use direction dir for direction and initialize it with 0. So in embedded, whenever you take any variable or flag, just initialize it with 0 because it may take some garbage value.
Okay.
So if you will not initialize it with 0 and it may take some garbage value, then your board can behave differently. So we have taken two variables. One is for duty cycle and another is for direction. Direction means it will turn on, the brightness will be turning on or it will be reducing. Direction will be increasing or decreasing. For that purpose, we have taken a flag type variable which is dir, direction. Now we want to observe our LED toggling continuously. So where we will write our this code?
While loop.
In while one loop. So in while one loop, we have section like user code begin 3. Here I will take a for loop. So for I will take int I and initialize it with 0. You all are aware with loops and basic C coding, correct? No?
Yes.
Okay.
Yes.
So I will take I from 0 and it will revolve around 4000. You can change it. I will show you by changing it also. And increase I with 1, I plus plus. Okay. This will be used for software PWM. It will work as PWM, but it's generated by software, so I'm giving it a comment like software PWM. Now we will start this for loop, and inside this, if uh, so, what will happen? This will act like this loop I equals to 0 to I 1000. It will act as PWM. So what it will do? It will generate its brightness from 0 to 1000, and after reaching 1000 the brightness will get back from 1000 to 0. So anyone have any issue till now?
How it generates from 1000 to 0? We didn't write any condition over here, right?
That we will see in this section. If block, it's for timing period. For example, if I will turn my LED on, then what will happen? It will constantly reach its maximum brightness, correct?
Yes, sir.
But for reaching that maximum brightness, it will take some fraction of seconds. So I'm using that fraction of second. For example, if it is reaching 100% brightness in 5 seconds, so what I am doing, I am taking a loop and I'm saying that for second 0 to second 2.5, it will turn on, and after reaching 2.5 seconds, whatever brightness it reaches, after that it will get diminished. So that's how PWM is acting there. Clear?
I think Chandan, you can continue with the code so we can get more clarity.
Okay. So now I will take if block, and if I is less than what duty cycle. So here what it will check, if I is less than duty cycle, then it will enter inside this and turn our LED on. So what we write with what we do when we want to turn our LED on? All, please repeat. All GPIO,
Right.
right? Please. GPIO, which port we have selected?
B.
PB5. So here we will select B pin 5. All GPIO pin 5, and what it will do?
1.
It will turn LED on. So I will use 1. Okay. LED will be on here. So first I will write the code, then I will explain. So
Yes.
it will turn this LED on. If not, then it will go into else code, else block, and just I will copy this, and it will turn this off. So for off, we will make this 0. Fine.
Yeah, sir.
Yes.
Okay. Now my loop will get closed here. Now I will check the direction. So for that, again, if dir equals to 0, In that case, I will increase my duty cycle, and once it reaches 1000, because we have taken loop of 1000 only. So once it reaches 1000, so if duty equals to or greater than 1000, so in that case, direction will be direction flag will be 1. Now I will close this loop.
Chandan, I think loop is already closed at line number 112.
No, it's for if
No,
block.
no, line 112.
Line 112, this loop is closed for for loop. It's for turning it on and off.
Okay, okay.
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 So for this if block, this block loop is closed there at line number 118. Now my duty cycle have reached the limit of 1000. Now I will decrease it. So in this other case, else what I will do, I will decrease my duty cycle, and once it reaches 0, so here I will compare like duty equals to 0. Then the similar steps which we have used above. So now instead of direction equals to 1, it will be 0, because it have reached 0. Now once again I will close my loop. Now my code is ready, but to observe, if you will use this code, first I will tell you with this code only so that you can understand the difference.
Chandan, can
I
you
will
please
build my
explain the code? So
yes, yes. Think, okay. Fine. Okay, so first I will explain this code. So there is a loop which will generate something like PWM. So that will generate like from 0 to 1000.
Okay.
So it will act like timer, not exactly timer, but it will act like timer. So what will happen here? It will monitor this loop for when my I flag I will reach from 0 to 1000. Let's say I have 1000 seconds. Okay, 1000 seconds is very large time, but I am giving an example. So let's say we have 1000 seconds time. So my PWM will work like it will start from 0 second and keep increasing till 1000 seconds. So my one duty cycle here is of 1000 seconds.
Okay.
Okay. Sorry, not duty cycle. My one cycle, my one wave cycle,
Is of
pulse cycle,
1000.
wave cycle is of 1000 seconds. For example.
Okay.
Now in this, I will increase my duty cycle. Okay. So uh, my duty is currently initialized to 0. Here it is 0. So once this I will start increasing from 0, it will reach 1, 2, 3, 4, 5. So once it starts its duty cycle, for example, it exceeds 0. So once it reaches 1, 2, 3, 4, 5, 6, 7, in that case, it will start to turn my LED on.
When duty gets start increasing,
When
right?
yeah, no, you can say it, but when this time cycle PWM cycle
No, but Chandan, in the first signal, when it
Yes.
starts from 0 to 1000, at that
Yes.
time only the else condition will work. Line number 111, because duty is 0 here.
Yes. So
So in the first
no,
signal,
no. Look at this line number 108.
okay,
Here, right now, I is 0
hmm,
and my duty is
0.
0. So both are equal. So I is
No, but the
one second.
condition
One
is
second.
okay, okay, okay.
Uh, so
Sir, we are
at
not
that
placing
time,
any equal to, less than or equal to. We are just
yeah,
placing like
I'm
greater than. It should be
yes. So let
placed.
me explain. Let
Sure.
me explain it. What is happening here? I is equals to 0 here,
Hmm.
and uh, I'll explain in the comment here for 1 second.
And duty is also equal to 0.
Yes. So here I equals to 0
Hmm.
and duty equals to 0.
Okay.
Okay. For first time. So
Okay.
is it will it enter in if condition? No,
No.
because it will enter in if condition only when duty will be greater than
I.
I. So it will not enter here, it will go in else
Hmm.
condition. So
Okay.
at that time my LED will be off.
Okay.
Then it will again get rotate. And once this duty exceeds my I cycle,
No, no, Chandan, but when in this loop, in the for loop, inside for loop, when I is equal to 1,
yes,
then too the LED will turn off. So for
yes,
first signal, I mean 0 to 1000 for first signal, it
it
will
will be in
continue.
off state. It will
Okay.
be in off state.
Okay, that is what.
Okay,
Hmm. Okay.
because
Okay.
initially my LED is in off state.
Hmm.
After completing first loop,
Hmm.
then my I will be again 0, and at that time duty will be 1.
Hmm.
So
Got it.
in that case, my I is 0 and duty is 1. In that scenario, it will enter this loop, if loop.
Hmm.
So what it will do then? It will turn my LED on. Okay, and this
Okay.
will continue. It will turn my LED on, off, on, off.
Yes.
So
Perfect.
till now we are clear.
Yes.
Okay, now it will go there. Line number 113.
Hmm.
Okay, so if my direction, which is initially 0, here I have set it 0, correct?
Yes.
So for the first time when my direction is 0, what it will do? It will increase my duty.
Yes.
So here what's happening? My direction is 0 and first time duty is also 0.
Yes.
Okay. Then once again when it will come, it will increase duty. So here direction and duty both are 0. So it
Yes.
will enter this loop, and here my duty will become 1.
Yes.
Go to 1.
Okay. Right. Then in this if condition it will check. So duty is 1. Is it equal to or greater than 1000?
Yes.
No. Duty
Equal
is
to.
1. Na? It's not equals to and neither it's
Hmm.
greater than 1000. So
Hmm.
it
Hmm.
will not enter this if case.
Hmm.
Again it will come here. Now direction is 0, but duty will be
1.
1. Then 2, then 3, then 4, and duty will keep increasing till 1000.
Yes.
Okay. In that case, my brightness will keep increasing from 0 to 1000. That's why I have set direction equals to 1. That means direction will be in on state.
Yes.
So it's increasing my brightness. Once this loop uh, makes this duty 1000 or more than 1000. So now what will happen? Duty will be 1000. So it will be equals to 1000. What
Yes.
it will do? It will set this direction flag 1.
Hmm.
Okay. Now direction is not equals to 0. Direction is 1. So it will not enter in this if loop. It will go into this else loop, and it will perform the opposite thing of what this if loop was performing. It will decrease, and then again when it reaches 0, it will set it 0.
Yes.
So I think there will be no doubt about regarding the working of this code till now.
So the conclusion is, as the duty value increases, the LED will keep
Brightness,
on
yes,
for more time.
yes, the brightness will keep increasing.
Hmm.
When the duty reaches 1000,
Hmm.
then from 1000 to 0.
Hmm.
When it will return back to 1000 to 0, at that particular time, my brightness will be
Hmm.
getting dim.
So Chandan, here you are taking word brightness just for explaining the concept, right? Because here
Yes,
we are
yes.
not. Okay, okay,
I'm just explaining the concept,
got it.
because if I will generate just PWM using timer and IOC file, you will not understand its working and its concept. So for that purpose, I'm using all these things using this software code only. Okay.
Okay.
Now I will build my code to check if there is any error. Zero error. Now what we will do, we will connect our board. I have connected it. I will run or debug my code. So just I will run my code. But before that, I will have to select my project. So PWM1 here, run. Okay. The code is successful. Now I will show it. So here, can you see this blue LED?
Yes, sir.
Can you see its brightness getting increased and then decreased? Just focus on it for around 1-2 seconds. Right now it's increasing.
So it's not stopping; it's just increasing and decreasing, right?
Yes, yes. Now it's decreasing. It have decreased. Now it will start increasing. Now it will start decreasing. It have decreased. Now it will again start increasing. So can every one of you see it getting increased, brightness getting increased and decreased?
Yes, yes.
Okay.
I have one doubt.
Okay. Yes, please ask.
For In order to control the LED brightness, we'll control with like a digital pin, right?
Yes.
In that, for controlling that, we'll use the PWM like 0 to 255. If it is 8-bit, then we'll use the 0 to 255 in that range, and
Yes.
we'll
And I
map
will
map
select
like
its pre-scalar and duty cycle.
yeah.
Okay.
So we'll map to in between 0 to 255, right?
Yes. Yes. When
In that
you
value,
will. Yes. Yes.
it reads the digital values and converts into analog value, and
Analog.
then
Correct.
yeah, it controls the LED, right?
Yes.
But here we are not doing like that. So I
Uh,
don't.
Pre-scalar, duty cycle, and digital frequency. These three things will we will see when we will use actual PWM. Right now we are not using actual PWM. We are just generating it using software code. I have already told it. Have I told it or not?
Yes.
I have already mentioned that till right now we will
Yeah,
use.
you have
Yeah,
mentioned, but anyway, we are reading we are assigning the LED value, right? Digital value.
we are ascending the LED value using
Yeah.
loop. That that loop is working as timer, not exactly as timer, but that loop is working as timer. And what this timer is doing, so if my LED is turning on and reaching its maximum brightness in 10 seconds, so in that 10 second, I have taken some time, like for example, 2 3 seconds. So what this code is doing, it it's making my LED turn on, and it's letting it go to its brightness and reaching its maximum brightness till 2 or 3 seconds, whichever we have taken. And once it reaches
Okay.
that time, then its brightness will start diminishing. So
Okay.
that's
Here,
how.
no conversion is happening, right?
No, no, no. These
Yeah.
things will happen when we will use actual PWM, and for that purpose, we will have to use some external LEDs, not the LED which will be inbuilt in this controller.
Okay.
And there you will not have to do anything. The software and IOC file will do all the things. You will have to just select your pre-scalar value and all. So from there, you will not be able to understand the topic of PWM much. And for that purpose, I'm explaining this using everything using this code only. So is it clear?
Yes.
Okay. So
Yes. Yes.
uh, have you all seen this, like the LED, its brightness getting turned on and then diminishing, or you have any doubt or issue regarding that?
Can you show it again, sir?
Yeah, just see this. These two are power LEDs, so just focus on this blue LED. Now it's decreasing. Okay, now it will
Yes,
increase.
sir.
Once it will reach its maximum brightness, then it will decrease once again,
Bec-
and
Okay, okay.
uh, this will keep moving in while one loop. So I think
See, Chandan, it is working
yes,
in my machine as well.
yes, yes. Okay, what you can do in the last line of this code, let me show it. Here you can add some delay, like all delay 2.
Okay.
Now, what will happen? You will be able to see its brightness getting on and off clearly, because it will give you some fraction of second delay to observe it with your naked eye.
But Chandan, I have one question that we haven't play with the dimness of light, right? We just turn on and turn off the light. So how it is making the light dim? That is my question.
Because the loop which we have used, that loop is working as timer. So what it's doing, it's telling the LED that you will start turning on and will keep turning on till 10 microsecond, for example.
Okay.
And after that 10 microsecond, whatever brightness you may have reached, after that you will start getting turn off For example,
Oh,
you
okay,
have
okay. Got it,
you
got it,
are
got it, got it, got it,
yeah,
got it. We have articulated that
yes,
concept. Okay.
yes.
Mm-hmm.
For example, you are on a field and you are running.
Hmm.
So the maximum speed by which you can run is 30 kilometers per hour.
Okay.
Okay, but what I am doing here, I am telling you that you are reaching 30 kilometers per hour maximum speed in 10 seconds.
Hmm.
So what will happen in first second your speed will be 1 kilometer. In second second it will increase, and after 10 seconds you will reach 30 kilometers per hour.
Okay.
But I have told you that after 5 seconds, I don't know whatever speed you have reached. After
Hmm.
5 seconds, you will decrease your speed.
Okay.
Okay. So what you will do? Your speed will start from zero until 5 seconds. You may have reached around 15 kilometers per hour,
Hmm. 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 Hmm.
and then after that, because 5 seconds timer is off, so you will decrease your speed, and from 15 kilometers per hour you will keep going till 0 kilometers per hour.
Yeah. Okay, got it.
So
Mm-hmm.
that's what happening with the brightness. We are actually playing with LED and its brightness right now
Hmm.
using our code only.
Okay.
Okay.
But
So
is this a way we can use it in a production? Just I'm just asking.
yes, you can. You will definitely use it in production. Uh, in railways, there are some systems, and we have LEDs like red LED, green LED, yellow LED.
Hmm.
Okay, and there for signal passing and everything, and to for driver to understand it, the
Hmm.
red LED represents danger, and its software is written for something that will stop some danger things to happen.
Hmm.
So for there, the brightness of red LED will be kept 100%, and the lesser other LED, for example, yellow LED, its brightness will be kept at 75%, and third LED, its brightness will be kept to 50%. At that time, what will happen if all these three LEDs turn on at same time? Then you may get confused that which LED I should focus on. But
Hmm.
we have set our priority that the red LED will help to uh, escalate the danger. That LED
Okay.
will help to reduce the danger. So that will make the driver focus first on red LED, because if you have three signals and one is very bright, other is dim, and third one is dimmest. So on
Hmm.
which signal you will focus first?
Bright.
Brighter one. So
Hmm.
in that way it can be used, but it's just an example. Its real life use cases are
No.
much
Okay.
more different and all.
Okay. Chandan, but my question is, uh, the way you have shown, like uh, managing PWM using software, that
Yes.
will use in production. That's what I'm asking.
No, no. The in production we will just use the PWM that will be generated from
Okay.
ID and all.
Okay. Hmm. Thank you. Okay.
Okay. So now